All right, welcome to the lunchtime video. In the last video, we set up a eBGP connection, and then we advertised some pretend routes into BGP. These are static routes that don't include an XHOP. They just include instructions for what to do. One of the instructions is install. That's to put it directly in the forwarding table without any sort of validation about whether it belongs there or not. And the other instruction was reject. And that said that if anyone tries to use this route, just send back a ICMP destination host unreachable message. So in addition to that, we used the passive knob in our BGP neighborship so that there was no race condition and the Wireshark capture looks a lot more clean. And finally, we looked at the routes being rejected by the import policy we included on router 1, where if a route is received through the protocol BGP and it has more than 5 communities as part of its community path attribute, that will not be installed in the routing table. So we saw how those went into the hidden routing table instead of the actual routing table because that import policy prevented it from going into the routing table. So where we left off is on the final verification commands for that. So we actually didn't see how we might have seen it just from looking at other things, but this is going to be the verification where we do actually go and look at that part specifically. So let's see here. So this is verifying BGP routes. Make sure that the routing table on R1 contains the expected BGP routes. So show route protocols BGP. That's interesting. Oh, right, it's protocol. And I saw this before, and I didn't think it was worth a downvote because it could depend on their implementation. I know what's going on. Anyone who's made it this far in networking probably knows that you can use protocol instead of protocols, or knows how to do PRO and see what the actual command is. So that's not worth a downvote. It looks like we're not getting the hidden routes. Looks like we've got 3 active routes and 0 hidden routes, but we don't have. So if we're not receiving those routes, let's take a look and see why that is the case. Oh, and we can see, aha, so here's the, I think the error where it, yeah, so it looks like I somehow got rid of all of that configuration. So I'm going to do rollback 1, commit, and I'm not sure what happened there. It might have been the bug actually. So let's make sure that everything is all set. So show pipe display set, and we're going to look for this static and export statics. Perfect. So where's the static? Here we go. So yep, so it's going to export statics, and then under that, yep, protocol static, add community 1, communities 1 through 10. So that looks good. Let's verify router 1. So router 1 didn't have those issues where it suddenly is not configured. And it looks like the import policy is still there. So I think we'll have better results now. Yep, so now we've got the results that they expected. We're going to have no routes in the routing table, but that's because we've got 2 routes that show up as hidden because that routing policy rejected them. So if I do hidden, now I can see those routes. So if I look at it specifically, show route protocol BGP hidden on that route, and then include a detail, hidden reason, rejected by import policy. So it's really nice and clear what's going on. So on router 1, change the community count configuration in the import policy. So now it's going to be or higher instead. So let's go ahead with that. So edit policy options, policy statement, import communities, term 1, show pipe display set relative. So from protocol, set from community count 5 or lower, then accept. But you can see this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 communities. So it's not going to be accepted. It's going to be, if I go up and then do that same command, we'll see term 2, which is going to reject that. But of course, if I go into term 1, as it's saying in the documentation, and I toggle this knob, so set, so instead of or lower, which is match, equal, or lower values, we're going to do or higher. So you can see that overwrote that configuration. I didn't have to delete the or lower. That's because this is a knob that applies to this specific command. So I'm just toggling the knob in different ways. I'm not adding a brand new command. I'm modifying an existing one, so it overwrites that automatically. All right, so let's commit the configuration, and you'll notice they have the good old-fashioned, commit is in the wrong hierarchy. Again, that's not worth a downvote. If anyone's made it this far in networking, they know you've got to go to the top level to commit. So I don't think it's going to really throw anyone out, and I'm certainly not going to submit downvotes for everything I see. I don't want to submit a downvote every 5 seconds. All right, so now let's take a look at the routing table again, BGP, and we'll see now that we're accepting routes with a community count 5 or higher. These routes that have a community count of 10 are no longer going to be hidden. They're going to be accepted. So let's look at one of them in more detail. And yep, so here's all the communities, and we no longer have that statement that said why it was being rejected or why it was hidden, because it is, of course, no longer hidden. So hidden reason, rejected by import policy. We no longer have a hidden reason because, of course, it's not hidden anymore. So, all right, let's do the next command. We're going to view the advertised communities. So that's what we saw before, I think. Yep, so this is what's going to be in bold. Yep, really straightforward, really easy. So the output shows that in device R1's routing table, the BGP routes sent from R2 are hidden. When the community count setting in R1's import policy is modified, the routes are no longer hidden. So really easy. I don't think there's anything too confusing about that if you understand what all the terminology means and you've run it through in the lab. So I feel confident in receiving a similar exercise like that, looking at the route, looking at the hidden table, seeing if there's anything in there, looking at the reject reason, looking at the configuration, so show configuration, pipe display set, pipe match community, or commune, and then yeah, so if I see any import communities, well, this is just a name, so it could be named anything, but I would be looking at the policy options, so show configuration policy options, pipe display set, and then I'd see anything, here we go, so community count, so anything like that is what I'd be interested in troubleshooting if there were an issue where routes were hidden when they were meant to be active, and it happened to be the case that the reason that was true is because of some sort of action applied to their communities, I feel very comfortable and confident in my ability to recognize and troubleshoot that on the exam. But let's do the rest of these here that I had ready. So looks like this is just a bunch of reading, and then there's going to be, this one I already did. Yeah, I remember doing this one, and this is the one that had the issue with where it said LSP. And this I just completed this whole thing. So if I actually open up this one, yeah, and you can even see that this is actually the exact same topic mapping, routing policies, communities. So this is a duplicate link. I already did that exercise. There's no reason to do it again, especially when I have so many other more topics to cover. So, but this is definitely going to be worth a look. It looks like it's, yeah, this looks very relevant, a lot more community things. So I'm definitely going to want to look at this. It looks like there's even more stuff that I somehow decided that it wasn't necessary for me to include. I'm kind of surprised I made that decision, that I wouldn't just include everything. But one thing that I might have been thinking is this is for peering. It says peering communities. So if there's a specific kind of community I need to learn about, peering communities, I would think that the other kind of communities wouldn't be as important. But I actually might want to add that into it just in case that shows up, because I know there is that difference between regular and extended. So I want to make sure I have some level of understanding of that. So I'm going to add this one, and then I will move on to the other topic. Of course, as I mentioned many times before, and yeah, and these are the examples. This one I just completed. So configuring a routing policy based on the number of communities. So yeah, this is the one I just did. It looks like it's separate. Then I redistributed it into OSPF, of course, or sorry, ISIS. It looks like this is another one I might want to do as well. BGP large communities. But at this point, I'm really kind of comfortable with this concept. So I definitely don't want to spend more time on it than I need to. But I think extended communities, regular communities, and then I will go ahead and add this extra one here. And then I'll be done with this topic. So let's look at configuring communities in a routing policy. The community is a route attribute used by BGP to administratively group routes with similar properties. One main role of the community attribute is to be an administrative tag value used to associate routes together. Generally, these routes share some common properties, but that is not required. Communities are a flexible tool within BGP. An individual community value can be assigned to a single route or multiple routes. A route can be assigned a single community value or multiple values. Networks use the community attribute to assist in implementing administrative routing policies. A route's assigned value can allow it to be accepted into the network or rejected from the network, or to modify its attributes. So there it is in plain English, everything I had learned from the previous example, and everything I feel pretty confident with. Figure one shows device one device R1, device R2, and device R3 as internal BGP, IBGP peers in an autonomous system AS 64510. Device R4 is advertising 172.16.0.0/21 address space from AS 64511. The specific routes received by device R1 from device R4 are as follows. So this looks like it would be really good because we took a deep dive into eBGP, but we did not look at IBGP in much detail. So this is going to be really valuable to go through. The administrators of AS 64511 want to receive certain user traffic from device R1 and other user traffic from device R3. To accomplish this administrative goal, device R4 attaches the community value of 64,511:1 to some routes that it sends and attaches the community value 64,511:3 to other routes that it sends. Routing policies within AS 64510 are configured using a community match criterion to change the local preference of the received routes to new values that alter the BGP route selection algorithm. The route with the highest local preference is preferred. And local preference, as we remember, is going to be a optional non-transitive. I'm going to need to check on that, but of course that's the whole reason I'm here, is to learn about BGP AS path attributes and to be prepared for troubleshooting them on the test. And actually, I do believe it's actually a well-known discretionary. I'm trying not to look at the answer here, but I thought they were optional, but I'm pretty sure they're well known. Optional would be a community string, but this is, I think, well known. I do have a kind of habit of second guessing myself and being right the first time, but nope, it looks like I was correct when I second guessed myself. This is a well-known discretionary attribute, so it may or may not appear in an update message, but it must be supported by any BGP software implementation. So that's kind of what I thought. Like communities, you can have an implementation of BGP where you don't include communities for whatever reason, but you cannot have any implementation of BGP where it doesn't support the local preference. You just don't necessarily have to include it in your BGP update messages, but you do have to include it in your actual implementation of BGP. Community strings, you don't. All right, so key things to remember: anything that's a well-known attribute in BGP, you're going to see no matter where you go. You're going to see a AS number, you're going to see a wait, and you're going to see a next hop. Those are the three things, and let me verify this. Oh, sorry, origin. So you're going to see the AS path, the origin, and the next hop. And wait is just a Cisco attribute. It's not even something you'll see in multi-vendor networks. So wait is completely wrong. I apologize for that. So the I don't know how I can remember this, but well-known mandatory, I'll just read it out loud. Hopefully that will help me remember. Well-known mandatory attributes must appear in every update message. It must be supported by all BGP software implementations. If a well-known mandatory attribute is missing from an update message, a notification message must be sent to the peer. Examples: AS path, origin, next hop. So one thing that's not clear to me is if the examples are all inclusive, because I would like to know what all of the well-known mandatory attributes are, because it, of course, is quite important if any are missing, because you'll get a notification. So I really like this here. I really like this. So I think I'm going to have this saved actually in my notes for BGP. So, and I'll probably even have it, I'm not sure where I want to save it. So let's see here. Peering communities. So, well, if the internet will stop ignoring me here. So we've got implementation, running policy. I'll just include it in here. So I'll do a new doc and I'll say, like, call it important notes or essential notes. And then this, I think, is going to be a really essential note. It really makes a lot of sense and is really, I think, clear about the differences between well-known and optional, and mandatory, discretionary, transitive, non-transitive. It doesn't give a explanation. I guess I'd rather have one, if I can find it, that gives you a brief description. So yeah, I don't see one, but I can certainly make my own. And I think I will do that. I'll just open up Paint, and then I'll put that picture in, and hopefully make it bigger. Yeah, there we go. And now I can include my own description here, because I really like this this description for well-known versus optional. So BGP well-known. So I remember reading something yesterday that was really clear about the difference between well-known and optional, and then going a level deeper. But it looks like most of this documentation is just speaking at a deep level for well-known and mandatory. It's not talking about the difference between well-known and optional. It's talking about the difference between well-known mandatory and well-known discretionary, optional transitive and optional non-transitive. I want a less detailed explanation. And I remember reading one yesterday. Aha, yeah, here it is. Kevin Wallace to the rescue. So this, I believe, was very, very clear. So well-known means all routers must recognize this path attribute. So let's add that into our explanation here. And choose a more relevant font size. Here we go. That looks pretty good. So yeah, I think I'm okay with that. Maybe I'll put it on 2 lines and then put it on top. So all routers must recognize this path attribute. That looks like a good explanation. And now we have optional. Optional means that the BGP implementation on the device doesn't have to recognize that path attribute at all. So we'll include that in here. Perfect. And now we've got mandatory and discretionary. So let's include some explanations in there. So mandatory means that the update must contain that attribute. So the update must contain that attribute. If the attribute does not exist, a notification message and the peering will be torn down. So let's include that. And hopefully try to fit it in a reasonable location. Maybe underneath maybe make the text really small and put it underneath. I think that'll work. Yeah, this looks like it's going to work. Perfect. Okay. All right, so now let's put in the explanation of discretionary. So it's, and thankfully it's a lot smaller of an explanation. So the attribute does not have to be in the update. So now let's put in explanations of transitive and non-transitive. So if transitive, the device needs to pass that path attribute on towards its next neighbor. And one thing I had wrong before and believed to be true, but have changed my mind, in light of the facts and evidence that I've been reading, is that transitive and non-transitive applied to BGP versus IBGP versus EBGP, but that's not the case. It just is talking about whether or not something is passed along to a BGP neighbor, regardless of if it's IBGP or EBGP. A transitive attribute will be passed on, but a non-transitive attribute will not. And of course, you don't have to pass on a transitive attribute if you create a import policy and remove the attribute. So if I receive a route with an extended community or a community or an aggregator, I can always create a import policy, remove that, and then when I pass it on to the next person, I no longer include that transitive route, but I have to take a special action to do that. If it were non-transitive and the MED, originator list, cluster list, NP reach NLRI, NP unreach NLRI, I would not have to take a special action to not forward that information on. One thing I'm not sure about is if I could add this information and continue it on, treat it as if it were transitive through a policy. That's something I'd be curious to know more about. About the kind of real world use cases of BGP attributes. So I'm sure, BGP is considered a very high level advanced topic. And this appears to be a major reason why, because of the complexity of the different options you have. So let's try to get like a good screenshot or save this or get this so that it's really visible and readable. So maybe I'll do a select on it. And then, yeah, there we go. And then increase the size. Oops, I'd like to increase the size of this, perfect. And now I can do a select on it and increase the size. Perfect, so yeah, everything looks really nice and readable. Everything can be done in a screenshot. So, oops, I'm gonna need a new screenshot. There we go. So now this is everything I need to know about BGP attributes. I need to know whether they're well-known or optional. And if they're well-known, I need to know whether they're mandatory or discretionary. If they're optional, I need to know whether they're transitive or non-transitive. And I need to know what are the well-known mandatory path attributes. We see that it's next hop, AS path, or origin. What are the well-known discretionary attributes? We see that it's local preference, atomic aggregate. What are the optional transitive BGP attributes? We see that it is aggregator, community, extended communities. What are the optional non-transitive BGP attributes? We see that it is the MED, originator ID, cluster list, NP reach NLRI, and NP unreach NLRI. And we know that with well-known BGP attributes, all routers must recognize this path attribute. We know that with optional BGP attributes, the BGP implementation on the device doesn't have to recognize that path attribute at all. We know with well-known mandatory BGP attributes, the update must contain that attribute. If the update does not exist, a notification error message will result and the peering will be torn down. We know that with well-known discretionary BGP attributes, the attribute does not have to be in the update. With optional transitive BGP attributes, the device needs to pass that path attribute on towards its next neighbor, whether IBG or BGP. This is where I had a misconception, but luckily that has been cleared up before I take the exam. And finally, we know that with optional non-transitive BGP attributes, it can ignore that attribute value. It does not need to pass it on. It can just ignore that. So if transitive, the device needs to pass that on towards it, can just ignore that. So that's kind of unclear. Like, I'd rather just say it does not have to pass it on than it can just ignore that, because what do they mean? Do they mean ignore it? Do they mean it doesn't have to pass it on? Or do they say it doesn't have to actually read and do things associated with the information inside? Because we're going to have an MED, originator ID. So does that mean that it's just not going to use the MED? It's not going to use the originator ID? Or does it truly mean that it's just going to pass it on, but the information in the NP, reach, NLRI is going to be received? So I really don't like this. It can just ignore that value. I don't think that's a clear way to actually explain what is happening. But that is, I think, enough of an explanation that I can handle, that I will need right now. So, oh, right. So I don't need to save that screenshot. I just need to paste it in here. And it's a little bit too small. See if I can make it bigger. So I think that's okay. That's readable. Yeah, now I can definitely read it for sure. So, oops, but it's a bit too, let's see here. Well, I don't want to spend too much time on this. There we go. I think that's perfectly readable. So I'll save that. And now anytime I can come back and I can, let me rename this. So BGP Path Attributes. And I can, if I forget about BGP Path Attributes, I can read that and get up to speed really fast. All right, so let's continue on with the reading. So I just finished here, and we know that local preference is a well-known discretionary attribute, meaning that every BGP implementation has to support it, but it doesn't have to be used. Oops. Yeah, it doesn't have to be included in the update message. All right, so let's continue on. On device R1, routes with the 64,511:1 community value are assigned a local preference of 200, and routes with the 64,511:3 community value are assigned a local preference of 50. On device R3, the reverse is done so that routes with the 64,511:3 community value are assigned a local preference of 200. And remember, it's the highest local preference that wins. So the local preference of 50 is not going to win over the local preference of 200. The routes with the 64,511:1 community value are assigned a local preference of 50. This information is then communicated through IBGP by both device R1 and device R3 to device R2. All right, so this is going to take quite a bit of setup here. I might just cut the video short because I don't know how valuable it's going to be to just see me reconfigure the lab. first thing I'm going to do is change the label I've got set up. So this is no longer going to be configuring a routing policy that filters routes based on the community. It's now going to be configuring communities in a routing policy. I'll take a screenshot of the lab in case I want to go and look at something else. And now I will axe these two routers, permanently delete those nodes, and get some fresh routers. I've found that kind of where you get problems with virtualization in GNS is when you've had routers running for a while and you have a lot of commits and a lot of like files and information in them. That's when you start to have problems, just because they've been modified a lot, and there's more kind of data there. There's more that can go wrong when there's more data. So I don't know what's happening here. It's something I don't want to happen, so I'm going to click no. And hopefully it does not happen again. Looks like I just selected the wrong. I selected the installation file, which I can delete. Yeah, unfortunately, doing updates to GNS3 is kind of its whole process, because the versions have to match. You can't link up to a GNS server that's a different version of what you have installed on your laptop. So if I were to do an update on my laptop, I'd have to make sure to update the version of my GNS server. So it's not as simple as just installing the update and you're good to go. You've got to make sure that they match, and then yeah, and then of course it's a different operating system on my server. I'm using ESXi as my operating system, and then here I'm using Windows 10. So there can be issues where there's a version update for Windows 10 GNS, but not for ESXi TNS. So there'll be different version numbers and it can be a problem. All right, for one more, this is going to be a 4-router topology. Yeah, I find like, yeah, I've been really happy with this lab so far. Like, you know, how much do you pay for your Xbox or whatever? Like this $600 server, like it's gonna pay for itself. I can do all this configuration here. I'm really happy with this. Unfortunately, as we saw in the previous video, you can't really use logical systems. You know, I tried to get that to work. I really hoped that that would work so that people could just use one router with logical systems and save themselves the kind of loss of functionality by not being able to emulate multiple routers. But as we saw, that logical tunnel interface just wouldn't, it just wasn't compatible. It wasn't coming up. It wasn't putting routes in the routing table. So it's pretty clear, and we saw with the show chassis FPC on it, that it's a virtual virtual FPC, virtual PIC in there. So I don't think you can virtualization like you would need special hardware in that PIC that was capable of creating those logical systems. And I do not have that because I am running software for my PIC. So I very clearly do not have that special hardware. All right, so this is to link the control plane to the forwarding plane. And one thing you'll notice too is I've just got squares for my icons. This is just a personal choice. I like the squares better. They're easier to click on. You can overlap them like this, really nice. And I just did a custom, so just right here, symbol browse. And this was just one of the symbols that was available, I think under classic, or I don't even know, circle. But yeah, here you go. So you can choose your custom symbol. It can be whatever you want. What I wanted was just a symbol that was easy to click on. And that could be stacked, so I could click on the control plane or the forwarding plane as needed. And of course, I'm going to be clicking. It's more important that I click on the control plane easily, because that's how I bring up the console window. So that's the one that goes on top. The forwarding plane, I really only need to click on to wire things up. And I'm only going to be doing that once at the beginning of the lab. Okay, so let's stick to the numbers here. So this is 0. So this is going to be 0. And this is 1. Now this is going to be 1, and this is going to be 1. And this is one thing that's kind of a bit not ideal. It doesn't map to the actual what shows up in the OS in GNS. There's kind of a disconnect between that, but it's not hard to catch on to. It's just the mapping in the OS is just going to be 2 less than what you see here. So gig 4, that's going to be G002. So yep, that's the one we're going to use for the connection between router 1 and router 3. All right, and then we're going to be using 5 to 5. And then finally 0 to 0. All right, and that'll align really nicely with the documentation. So let's bring up these nodes. Oops, and it looks like maybe I didn't click on them. Okay, there we go. So now they're coming up, and they're going to take a while to come up. I think the longest part is like the wake up daemon part. It gets stuck there for a few minutes. So I think I'm going to stop the video here because it's going to take a while to come up. And then in the next video, we're going to be doing this exercise for BGP communities. And then we've just got 2 more to get through after that. And then we'll be moving on to the next topic. So see you in the next video. Thanks for watching.